So today our group will present about Wolsong Nuclear Power Plant. This is our group members. First is Nur Alia Sofia. Second is Azin Khayat, Aina Najib Muhammad. In our video, we will focus on 5 components which are introduction, background, alternative solutions, proposed solutions, and recommendations. So this is a picture of Wolsong Nuclear Power Plant, which is located at Gyeongju, North Gyeongsang Province, South Korea. It has 6 reactors. 4 unit Wolsong of Can-Do 6 reactor. With Wolsong 1, the construction began on 30 October 1975, and this Wolsong 2 is the second Can-Do, and the construction began in 22 June 1992. Next is Wolsong 3, and the construction began in 17 March 1994. And lastly is Wolsong 4, which is the fourth Can-Do, and the construction began in 22 July 1994.
In this video, we're gonna focus more on Can-Do. Can-Do is used to generate electricity by using natural uranium fission. And this fission will generate heat, and this heat is used to generate electricity. Okay, now we need to know the main component of Can-Do to understand how it works. The first component is the core, the main core, which is placed horizontally, and it is in form of cylindrical tank called calandria, and inside of it is the fuel channel run from one end to the other end of the calandria. Next, fuel. If we don't have the fuel, this Can-Do will never works. And Can-Do use uranium oxide, natural uranium oxide. Next, Can-Do also use moderator because it slow down the neutron release from the fission and will cause more fission and sustain the generation of the uranium fission. As I mentioned before, Can-Do will generate heat to generate electricity. So it is important to have coolant that will prevent a meltdown that will halt the energy production, and this coolant will circulate through a nuclear reactor core to transfer the heat from the core to steam generator. And why? Because the heat will transfer first to the heavy water, and then the heavy water will go through a steam generator to produce steam from natural or common H2O, not heavy water. Steam generator will produce high pressure steam, so this steam will be moved to steam turbine, and the pressure from the steam will cause the turbine to move, act as a big magnet to produce electricity. And the last one is electrical generator, so it will change the movement of the steam turbine to electricity, and then the electricity will be distributed to the grid. Can-Do use heavy water. It is one of its specialty. Common water is a good moderator, but it will absorb neutrons, so the fuel used must be enriched. But in Can-Do, the use of D2O, make it possible to use natural or non-enriched uranium. Actually, instead of the common H2O that we use, heavy water is D2O. It contains heavy hydrogen or deuterium, and normal water just have normal hydrogen. Heavy water is actually about 10% heavier than H2O. Heavy water actually can be extracted from natural water sources.
So there are 2 alternative solutions. First, we need to determine if the source of heavy water is coolant or moderator. The second one is we need to investigate if there were recent heavy water handling activities. So the heavy water leak could have occurred during heavy water handling. However, if there were no such perceived leak during heavy water handling activities, then leaks may have been caused by system components.
We have two proposed solutions, which are change packing replacement method from traditional to automatic and change centrifugal pump to air AODD pumps. The friction of the shaft rotating, it wears away at the packing over time, which leads to increased leakage until the packing is adjusted or repacked. Packing around the shaft should be tightened just enough to allow about 20 drops per minute. If the follower cannot be properly adjusted anymore, the pump needs to be repacked with the proper packing. Nuts and bolts are one of the most basic and commonplace components in any piece of assembled equipment and can be considered as the traditional method. To obtain a leak-free flange connection, a proper gasket installation is needed. So, to address this challenge, there needs to be a seal between the shaft and the pump housing that can contain the pressure of the process being pumped and withstand the friction caused by the shaft rotating. So we have the automatic methods that we have three. First is spring, second is pneumatics, and third is hydraulic. For the spring, the coils are compressed or extended linearly, which creates a force that opposes that motion. Once the load is released from the spring, it will oscillate linearly back and forth. Second, the pneumatics use the force of compressed gases to generate mechanical effects. The pneumatic pumps, in particular, use compressed air to create force that is used to move fluids through a piping system. Pneumatics is capable of creating extremely amplified levels of pressure that can generate surprisingly large amounts of power, as well as hydraulic too. The last one is hydraulic. The pump uses a direct application of force to a movable volume of liquid to squeeze the hydraulic fluid and pressurize it. Hydraulic, rather than pneumatics, operate at higher pressure. Hydraulic systems are high cost, usually more complex, and require maintenance personnel with higher skill. The second one is centrifugal pump to air operated double diaphragm AODD pumps. It is as simple as two valves opening and closing. You can see here and here. Using air pressure to force a piston back and forth, or as complicated as delicately balanced vanes that are revolved by the air. The use of an air motor on this type of pump allows it to be used in more than one application. There are three reasons why AODD pumps are better. For the first one, centrifugal pumps do not operate well when being run too far off the middle of the curve. If a lower or higher flow is needed, efficiency is reduced or can result in cavitation damage. Second one, the AODD pumps have stall capability. If pumping pressure increases in an application, an AODD pump will easily deadhead. Meanwhile, a centrifugal pump will continue to build pressure until something fails. The pump is severely damaged or both. Some liquids can vary in viscosity due to temperature or chemical reaction. A rise in viscosity alters the flow rate and efficiency and increases pressure. Lastly, the metering. AODD pumps are an ideal choice for metering applications. They deliver constant flow, allowing them to easily meet process requirements.
Next, the recommendations. The maintenance process of the reactor component shall be supervised by a competent person. A competent person shall be a person who has been certified that he is duly qualified to supervise the maintenance process of the reactor component. The competent person must have skills and understanding about the maintenance process. An owner or occupier shall ensure that a competent person is on duty at any time the reactor is in operation. It is the responsibility of that person to make any inspection. Next, the operator of nuclear installation must periodically repeated training and exercise for emergency personnel to qualify them by providing through knowledge or emergency duties. My next point is public, particularly residents who live around the nuclear facilities. Their knowledge and attitude to nuclear power will play an important role. Therefore, increasing the knowledge of nuclear power and radiation raising public awareness of nuclear emergency, and carrying out health education to residents around nuclear power facilities are particularly important. And everyone must play their roles to ensure a similar incident never happen again. That's all from us. Thank you for listening.